Hi guys, Maayong adlaw. Welcome to NatzMath TV. So for this video, my presentation is about solving quadratic equations by extracting square root. For the lesson objective, at the end of this video, you should be able to solve quadratic equations by using extracting square roots. So before we proceed to our examples, let us review first the general form for quadratic equation. Quadratic equation is expressed in ax squared plus bx plus c is equal to 0, wherein a is the coefficient of x squared, and b is the coefficient of x, and of course our c is constant, and the general form is always equated to 0. In preparation for this topic, we have to review first about the different laws of exponents involving radicals. For example, we are given the square root of x. We have to take note that in this expression, our x here is assumed to have an exponent 1. And we also have assumed index 2. So if in radical expression, if the index is not being specified, it is assumed that the index is 2. That's why this is called a square root. So for example, we are going to change this one to exponential form. We can express this one as x raised to 1/2. Where did we get 1? It is the assumed exponent 1 here of x, and the denominator 2 here is the assumed index here, which is 2. So therefore, the square root of x in exponential can be written as x raised to 1/2. Now, for example, we are given this expression, the square root of x squared. So if we are going to change this one to exponential, so we can express this one as the x, which is the base here, and the 2, the exponent of x, which is 2, is in the numerator, and of course, our index, assumed index in the radical, which is 2, that's why here we have 2. Since 2 over 2 is just simply equal to 1, so this expression can further be written as x because x is assumed to have an exponent 1. So therefore, the square root of x squared is just equal to x. Now moving forward, let us also recall about the perfect square numbers. What are these perfect square numbers? These are just some examples of the numbers which are perfect squares. When I say perfect squares, these are numbers having perfect square root. Meaning, for example, the square root of 1 is 1. Why? Because when we multiply 1 two times, because this is square, we can say 1 times 1 is 1. And the square root of 4 is 2 because 2 times 2 is 4. The square root of 9 is 3 because 3 times 3 is 9, and so on until 400. The square root of 400 is 20 because 20 times 20 is 400, and so on. So we still have 21 times 21, 22 times 22. So we'll just focus in these 20 numbers. Okay, so I hope you could memorize these perfect square numbers even up until 20 times 20, which is 400. So let us proceed to example number 1. For example, you are given x squared minus 49 equals 0. And of course, we are going to solve for the value of x. So what value of x that will make this equation a true statement? So what we need to do in this equation, we need to use extracting square root because 49 is a perfect square. And of course, x squared is also a perfect square. So how to solve this one using extracting square root? First step is to isolate our variable at the left side of the equation and a constant at the right side of the equation. Since we have the 49 here as our constant, so we need to transfer this 49 to the right side of the equation by using the addition property of equality because this is minus. So we need to add 49 at the left side of the equation. And of course, we also need to add 49 at the right side of the equation in order for us to maintain the balance of the equation. So this time, we have here negative 49 plus 49 is of course 0, or this can be cancelled out. So what remains at the left side of the equation is the x squared, and of course 0 plus 49 is 49. This time, we have x squared equals 49. We will now apply the extracting square root. We need to extract square root in order for us to eliminate the exponent of x here. we need to extract square root at the left side of the equation, the same thing also at the right side of the equation. So this becomes the square root of x squared equals the square root of 49. In this case, just as I have mentioned earlier, the square root of x squared is just simply x. So we can cancel out the radical and the exponent too. So therefore, what remains is the x. Then equals the square root of 49 is of course plus and minus 7. Why? Because when we multiply, positive 7 times positive 7 will give us positive 49. And of course, negative 7 times negative 7 will give us positive 49. That's why we have two values for x here, the positive 7 and the negative 7. Now let us check if these values of x, positive 7 and negative 7 is correct. So let's go back to our original equation, which is x squared minus 49 equals 0. The values are positive 7 and the negative 7. We will check first for positive 7. We will substitute this value to our equation. So this is x squared. So that's why instead of writing x, we change that with the value which is positive 7. So that's why it becomes 7 squared minus 49 equals 0. 7 squared, or the square of 7 is 49, of course, minus 49 is equal to 0, so that is 0. Let's proceed to the second value, which is negative 7. So the same process, we change the value of x here which with negative 7. So this is negative 7 quantity squared minus 49 equals 0. So negative 7 squared is positive 49 minus 49, which is equal to 0. So therefore, the values are correct. Now, next example. Let's proceed to example number 2. For example, you are given 3x squared minus 12 equals 0. So the same process, we isolate the variable at the left side of the equation and the constant at the right side. So our constant here is negative 12. So the same, since this is negative, we need to use addition property of equality in order for us to cancel the negative 12. So what remains at the left side of the equation shall be 3x squared and of course our 12 here, that is 0 plus 12. So we have here 3x squared equals 12. Now this time, since we have here the coefficient of x squared, which is 3, we need to eliminate first the 3 before we can extract the square root. So to eliminate the 3 here as the coefficient of x squared, we need to divide both sides of the equation by 3. That's why you can cancel out the 3, and what remains is the x squared. Then 12 divided by 3 is 4. Now this time, we can now extract the square root at the left side of the equation at the same time at the right side. So this becomes the square root of x squared equals the square root of 4. Then we can cancel out the radical and the exponent. What remains at the left side shall be the x. Then the square root of 4 is plus and minus 2. So our values for x are positive 2 and the negative 2 for this specific quadratic equation. Now let's proceed to our checking. We go back to our original equation, which is 3x squared minus 12 equals 0, and our values are positive 2 and the negative 2. We will substitute the first value to our original equation. That's why we have here the 3. We copy the 3. Instead of writing x, we change that with the value of x, which is 2. Then we copy the square. Then we copy negative 12 equals 0. Then we square this part here, which is 2 squared. So that gives us 4. 3 times 4 is 12. Minus 12 is, of course, 0. So therefore, we got a balanced equation for the first value. Now let's proceed to our second value, which is negative 2. The same process, we substitute negative 2 to the equation. So we copy 3. Then instead of writing x, we change that with negative 2 quantity squared minus 12 equals 0. So negative 2 squared is 4. Then times 3 is 12 minus 12 is 0. So therefore, we got a balanced equation for both values, positive 2 and the negative 2. So therefore, our values are correct. Now let's proceed to our last example. This is example number 3. This is example number 3, not example number 2. For example, you are given 4x squared minus 25 equals 0. We isolate our constant at the right side and the variable at the left side. So what remains at the left side shall be 4x squared by addition, property of equality, so that is equal to 25. Then, eliminate the coefficient of x squared, which is 4, so divide both sides of the equation by 4. We cancel out the 4. What remains at the left side shall be x squared. Now, since we cannot divide 25 by 4, so we will just simply copy 25 over 4. And since 25 is a perfect square and also 4 is a perfect square, so therefore we can extract the square roots. So this becomes the square root of x squared equals the square root of 25 over 4. So the square root of x squared is of course x. Then the square root of 25 over 4 shall be plus and minus 5 over 2. The square root of 25 is 5 and the square root of 4 is 2. That's why we have here positive and negative 5 over 2. So let's go to our checking. The original equation is 4x squared minus 25 equals 0. The values are positive 5 over 2 and the negative 5 over 2. Let us check the first value. So we substitute 5 over 2 to the original equation. We copy 4. Then our x is 5 over 2. Quantity the square minus 25 equals 0. Then we square 5 over 2. This 5 squared is 25 and 2 squared is 4. This time we have two choices. It's either we multiply 4 to 25, which will give us 100, then 100 divided by 4, that would give us 25. Or you just simply cancel out directly the 4 here as the coefficient and the denominator here. So what remains is the 25 minus 25 equals 0. Now let's proceed to our next value, which is negative 5 over 2. So we do the same process. We substitute negative 5 over 2 to the original equation. So that becomes 4 times negative 5 over 2 quantity squared minus 25 equals 0. So negative 5 over 2 quantity squared, of course, will give us 25 over 4 because this is negative. Negative times negative is positive. Then we can also cancel out the 4. Then what remains is 25 minus 25 equals 0, which is equal to 0. Okay, that's it. I hope you have learned something from this video. If you have any question, you can just comment down below or you can message me in my Facebook account in the description box. So, for now, that's it. Thank you and God bless.